Hi everyone, this video is an exercise 13 of the challenge question. So this is part D of the first question. So we want to basically we have the function f of x, which is x times 3 minus x, and we found the area of the finite region in part A. So the area of the finite region bounded by the curve and the x-axis for the function f of x was 9 over 2, and we also solved parts B and C. Now, in this question, we want to do part D. So we want to find the area when there is a translation on the x-axis, basically x plus a is just a translation, horizontal translation. So yeah, we want to see what happens. I can right now tell you that when there is the area basically stays the same because there is only horizontal translation. So um, it doesn't affect the area. So still the answer is 9 over 2. But since we want to show that mathematically, we need to use a technique that you will learn in Pure 2. So if you haven't already, the proof may not make sense now. But when you once you learn use substitution, then this is going to be very easy. So in this question, the first thing that we do is that we basically just we know that, right? The new function is f of x plus a, so there is translation. And first of all, the first thing that we should do here is that we can simply just substitute x plus a into f of x. So we can write that the function becomes x plus a times 3 minus x plus a. So like this, x plus a times 3 minus x minus a. Now, we want to find the roots because, again, we just want to know that, okay, what are the x-intercepts of this curve? So either the first bracket is equal to 0 or the second bracket is equal to 0, which means x is either equal to minus a or x is equal to 3 minus a. And these two are actually the bounds of the integration, or the limits of the integration, because the region is between minus a to 3 minus a. So the integral, basically to find the area, is now minus a, and then the upper limit is 3 minus a, so f of x plus a dx. I think so far it's just a standard integration. I mean, the steps are standard, but from this part onwards, we need to use substitution. So we can use a substitution that let u be equal to x plus a, because we want to get rid of this x plus a and just have just one single variable inside. So we want to turn the integral basically into something that is just one variable. So as a result of that, we need to find du. So du dx is just equal to 1, which means du is equal to dx. And also we need to change the limits. So again, these are pure 2 stuff. So if you haven't done pure 2, then maybe it's a good idea to skip this part. So yeah, now we want to know what are the bounds. So we said that x is equal to minus a, so we just substitute that into u. So when x is equal to minus a, what happens is that u is minus a plus a, which is equal to 0, so that's the new limit. And also when x is equal to 3 minus a, then u is equal to 3 minus a plus a, which is 3. So these are the new limits, which are 0 and 3. And so the new integral becomes 3 minus a f of x plus a dx. And we can then substitute the things that we found. So 0 and 3, and then f of u inside and du. Okay, now this is the interesting part, because this integral is actually equal to 9 over 2. And it's because that this we already knew the original area of f of x between 0 and 3, which was 9 over 2. And the reason that f of u is also 9 over 2, because it's just another function, I mean the same function that has no translation anymore because a was the constant. And because of that, we still get 9 over 2. So the area basically stays the same, just moves horizontally, but it doesn't change. The value doesn't change. So basically sliding a graph left or right doesn't change the shape. So that's the whole point. Since the shape doesn't changes, so the value of the area stays the same. So therefore, the area doesn't change.